Dear students, today we will discuss about important terms in electronic spectroscopy. First one is chromophore. Chromophore is a group which shows characteristic absorption in UV visible region. It means that such a group which will absorb light or radiation is called as chromophore. For example, in case of cyclohexanone, carbonyl group is a chromophore because it will absorb radiation. So it is simply a group which is responsible for absorption of light. Now second term is oxochrome. An oxochrome is a group which assists the chromophore in absorption of light. Oxochrome brings about a shift of absorption band towards longer wavelength. It is also called as red shift. See here, what happens? A chromophore absorbs radiation, that's okay. But an oxochrome which is present along with chromophore, that will help the chromophore to absorb the radiation. So such a group is called as oxochrome. For example, in case of para-hydroxyacetophenone, carbonyl group is chromophore because it will absorb radiation, but the OH group which is present, it carries an electron pair that will assist the chromophore to absorb the radiation, and therefore it is called as an oxochrome. So these two terms are very fundamental terms. One is chromophore, other is oxochrome. Now next term, which is also very important, bathochromic shift. See here, whenever you place a compound in UV radiation, it will absorb radiation or light, and which will give you a signal in UV spectrum. That is called as absorption band, and that is reported in nanometer. For example, if you put para-hydroxynitrobenzene in UV radiation, it will absorb at 255 nanometer. That is called as absorption band. Now what is red shift or bathochromic shift? A shift of this absorption band due to presence of an oxochrome or solvent effect towards the longer wavelength, that is very important, towards the longer wavelength is called as bathochromic shift or red shift. See here, para-nitrophenol, or you can call it as para-hydroxynitrobenzene, when it is placed in alkaline medium, it will absorb at 265 nanometer. Before it was absorbing at 255 nanometer, but now it will absorb at 265, longer wavelength, and therefore this is called as the bathochromic shift. Now what is hapsochromic shift? It is exactly opposite to bathochromic. It is also called as blue shift. A shift of absorption band towards shorter wavelength is called as hapsochromic shift. Now see here, aniline that was absorbing at lambda max 230 nanometer. So absorption band is at 230 nanometer for aniline. But when you place it in acidic medium, lambda max becomes low, means same aniline on treatment with HCl will produce a salt, and that will absorb at shorter wavelength, lambda max 203 nanometer. So such a shift of band towards shorter wavelength is called as hapsochromic shift or blue shift. So always remember these four terms: chromophore, oxochrome, bathochromic shift and hapsochromic shift.